Hello, my name is Nurul Azrin Ardini Muhammad Zohan. I'm from MTH3101 Group 3. So, I'm going to present the 7th theorem that is included in Advanced Calculus Chapter 1, which is the first one is Rolle's Theorem, second, Mean Value Theorem, third, Intermediate Value Theorem, and fourth, the Cauchy Mean Value Theorem, fifth, the Taylor's Theorem, and the next is Maclaurin's theorem, and last but not least is the second mean value theorem. Alright, firstly we have here is Rolle's theorem. For Rolle's theorem, let f be a continuous function in closed interval AB and differentiable in open interval AB. So the characteristic of the Rolle theorem is when fa equals to fb equals to 0, which means here is the location of fa is 0 and fb is also 0. So there is at least one point C, which is f prime C equals to 0. This means the gradient of the tangent line is parallel to the x-axis. So the gradient is 0. For the next theorem, which is mean value theorem, it is the gradient of the function at point C is equivalent to the gradient of the secant line of the graph fx. So the formula is f prime C equals to fb minus fa, fb minus fa over b minus a. So let me show you another example, which is alright. So we have A and B, which A is less than B, and we will have FA here, FA also less than FB. I'll show you FB. So we can make the graph a continuous graph. Let me do it like this. Alright, so we have the secant line here. This is the secant line of the graph fs, and we make one point C around this interval. So I make it here C. So this is the C, and the gradient of this graph at point C is parallel to the gradient of the secant line of the graph. So let's see the comparison between the Rolle theorem and the mean value theorem. So let us see this back. For Rolle's theorem, it is if fa equals to 0 and fb equals to 0, which means the graph may look like this. Then there is at least one point C in the interval AB. Between A and B, we have C here, such that f prime C is equals to 0. It means the C is the maximum point of the graph, and the tangent line at point C is parallel to the x-axis. Alright. Meanwhile, for the mean value theorem, for the function is same like before. Let f be a continuous function in closed interval AB and differentiable in open interval AB. Then there exists at least one point C in element of in AB, such that f prime C equals to fb minus fa over b minus a, which refers to the gradient of the secant line of the graph. Alright, so that is the comparison between Rolle's theorem and mean value theorem. So next we have intermediate value theorem. So intermediate value theorem is if f is a continuous function in AB where a is less than b, then there are at least one L where L is between fa and fb, then there is at least one x in between a, b, such that fx equals to L. So I provide you two examples here. So let's see. The first one is A is here and B is here, A less than B, and we have FA here and FB here. So we have this graph, and we choose 1L here, 1L between FB and FA, just like the condition here. So L we read L is equals to Fs. Alright, so the next example, I use different shape of graph. So for this graph, I have A and B, A less than B, and FB greater than FA. I choose one L here and read here. So L is equals to Fs. So next, we have the Cauchy mean value theorem. Okay, let's see. Let f and g be both continuous on AB and differentiable on AB. This one is closed interval and open interval AB. Then there is some point C, which is C is between A and B, such that G prime C times FB minus FA is equals to F prime C times by GB minus GA. This formula is actually come from this formula, FB minus FA over GB minus GA equals to F prime C over G prime C. So this is what they call the Cauchy mean value theorem. So now, let me show you the example of the Cauchy mean value theorem of Fs 3x plus 2 and Gs x squared plus 1 in the interval 1, 4. So firstly, we will do the derivation of Fs, f prime s, it is 3, and so we will have f prime c equals to 3 also. And for g prime s, we will have 2x. So for g prime c, we will have 2c. Now, we'll do FA and FB. So for A is 1 and B is 4. So we have FA equals to 3 times 1 plus 2. It is 5. And FB is 3 times 4 plus 2 is 14. Right? So we'll move on to G. Sorry for that. So GA will 1 square plus 1 is 2, and GB 4 square plus 1. So we'll have 17. Okay, so we make the Cauchy mean value theorem here following this formula. So we have we have FB minus FA equals GB minus GA will equal to F prime C over G prime C. Sorry for the noise. Okay, so we will just substitute the formula. FB minus FA, it's 14 minus 5 over GB minus GA, 17 minus 2. We will have, F prime C, 3 over G prime C is 2C. Okay, so now we will have 3 over 2C equals to 9 over 15. So we can have C equals to 5 over 2, which is in the interval of 1, 4. So that is Cauchy mean value theorem. So our next formula, the fifth formula, is the Taylor's theorem. So this is the formula of Fs. Actually, for Taylor's theorem, it has the general formula, which is Fs equals to P and S plus R and S, which is P and S is referring to the polynomial of S plus the remainder R and S. So this is the formula. Fs equals to f of a plus f prime a times by s minus a plus ... until fn of a over n factorial times by s minus a power of n plus the remainder. The remainder is f power n plus 1 of c over n plus 1 factorial times by s minus a power of n plus 1. So c is the sum point which is located between a and s. Okay, so next we have Maclaurin's theorem. It is almost similar to the Taylor's polynomial. So this is the formula. f naught plus f prime of 0x plus dot 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 until f n minus 1 of 0 over n minus 1 factorial as n minus 1 plus fn of 0 over n factorial times by x minus n. So we have a is equals to 0 for the Maclaurin's polynomial theorem. And next, last but not least, we have second mean value theorem. This happens to a normal Taylor's polynomial with n equals to 1. N is the order of the polynomial, and C is the point where between between A and X, and this is the formula: Fx equals to Fa plus F prime X times by X minus A plus F double prime C over 2 factorial times X minus A power 2. Okay, this is the comparison between the Taylor's theorem, Maclaurin's theorem, and the second value theorem. Actually, for both Maclaurin's theorem and second mean value theorem is the derivation or another special case for the Taylor's theorem. Okay, this is what I mean. Okay, in general, this is the Taylor's theorem, which is f(s) is equal to the polynomial of s plus the remainder. Okay, so we have here P and S equals to this formula fa plus f prime a times x minus a plus dot 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 until the fn of a over n factorial times by x minus a power n. And for the remainder is r and s with f power n plus x n plus 1 and of c over n plus 1 factorial times by x minus a n plus 1. Okay, this happens when c is located between a and x. Alright, for some cases in this Taylor's polynomial, we have another name, which is, the first one is when n equals to 1. It means the order of the polynomial is 1. So we have fs equals to fa plus f prime x times x minus a plus f double prime of c over 2 factorial times by x minus a equals power 2. This is the second mean value theorem. And for the case of a equals to 0, we just substitute 0 here for the a. So we have this formula, which is fs equals to f of 0 plus f prime 0x plus f double prime 0 over 2 factorial x square plus dot 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 until the fn of 0 over n factorial times by x power n. This is the Maclaurin theorem. So for example of Taylor's and Maclaurin's theorem, let us do this question. So find the Taylor's and Maclaurin's theorem for fs equals to ln s of order 3 about 2. So first step, we'll do the derivative first. So fs is ln s, f prime s is 1 over x, and f double prime s is negative 1 over x power 2, and f triple prime s equals to 2 over x power 3. So we substitute the x with 2, so we have the value f prime 2 is 1 over 2, f double prime 2 is negative 1 over 4, and f triple prime 2 equals to 1 over 4. Alright, so for the Taylor's polynomial, we will have f2 plus f prime 2 times by x minus 2 plus f double prime 2 equal over 2 factorial times by x minus 2 square, and we have to sum it up with the remainder also. It is f triple prime 3 of 2 over 3 factorial times by x minus 2 power 3. So we will have this polynomial of order 3, and this is the remainder. So for Maclaurin's polynomial, we will have, for Maclaurin's, we will have f2 plus f prime 2x plus f double prime 2 over 2 factorial x square plus f triple prime 2 over 3 factorial x power 3. So we substitute the value. This is ln 2 plus 1 over 2x minus 1 over 8x squared plus 1 over 24x power 3. So we have the remainder. For Maclaurin's theorem, it is 1 over 4 times by x power 3. Meanwhile, for the Taylor's polynomial, we have 1 over 4 times by x minus 2 power of 3. So in conclusion, this value is obviously less than this 1 over 4 times by x minus 3. So this means the remainder for Maclaurin's polynomial is less accurate compared to Taylor's polynomial. Alright, thank you.